Welcome to July 27th LeetCode Challenge. Flatten binary tree to linked list. Given root of binary tree, flatten the tree to a linked list. A linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child pointer is always null. The linked list should be in the same order as a pre-ordered traversal of a binary tree. So pre-ordered traversal, meaning it goes as such: 1, 2, 3, 4, 5, and 6. And that's basically the linked list we get. So basically we just return 1 null, 2 null, 3 null, and then so on, right? And then it was empty root, return empty. If the root has one node in it, return the one node. Constraints of the number of nodes in the tree is ranging between 0 to 2000, and each value of the node to be -100 to 100. So let's try this with constant space if we can. So let's think of an algorithm. So say you initialize an empty stack, right? So say we're going to use a stack for this, and we're going to initialize an empty one, and then we set a current variable to root. So what we're going to do is actually store our binary tree inside a stack and then just put it back together. So while current exists, what we want to do is if the current node dot right exists, then we want to append to the stack, and we want to append the value of the node of current right. If the current left node exists, then we also want to append that to the stack as well. So stack.append current left. Alright. If current actually no, we don't want to append it to the left, I should say. We want to make sure that we update the current right to be the current left. And then assign current left to be none. As such. So basically we just move the left node to the right node. Else, if the stack exists, we are going to add that current right to be stack.pop. And then we exit this loop. Current is equal to current.right, and then return the root because we don't modify the root. We modify the root in place, and this should work. So this is basically using a stack where we still have the left and a right subtree. Let's submit this. Alright, this is not really using a big O of n time complexity, or big O constant space, I should say. No, it's using a stack for extra memory. I mean, it works. We'll call it a day. The time complexity is big O of n because we have to loop through each node in the tree, binary tree, and memory extra space would be big O of n because we use our stack as well, which is not optional, but it'll work. Alright, have a great day, everyone.